So in this video, we will learn average speed and average velocity. So this average speed and average velocity tell us how fast an object is changing its position with respect to time. Average speed gives us only magnitude, but it does not tell us about the direction of the motion. But average velocity gives us magnitude as well as the direction also. So let's see what is an average speed. So average speed is the total path length traveled by an object divided by the total time interval during which the motion has taken place, and its unit is meter per second. And since it gives us only the magnitude, so it is an scalar quantity. So let's now see this graph where we had described the motion of an object with respect to time. So on the y-axis we have the distance x in meter, and in the x-axis we have the time in second. So an object initially, that is time t equal to 0, is at this point. As the time progressed, it started moving to point A, then point B, then point C, and then from and to the point E. Now one main point to understand, since the slope at every point is different, so this motion is a non-uniform motion. So what we can say, since dx by dt, that is the slope, is not equal to constant, so this is non-uniform motion. Non-uniform motion. I hope this is clear. So now we will find the average speed when an object is going from this point and reaches to this point at some time equal to t. So let's calculate the average speed. Average speed for O to D. O to D motion means when an object is moving from this point and finally come to point D. So what will be the average speed? By looking at this graph, the average speed will be average speed. So what average speed tells us is the total path length divided by total time interval during which motion has taken place. So what will be the total path taken by an object? This will be from 0 to this point. What is the total distance? 80 meter. So the object has covered 80 meter of distance, and how much time the object has taken from this point to D point? The object has taken 10 seconds. So time is 10 seconds. So you will see you have 8 meter per second of average speed when an object travels from O point to D point. Now let's again calculate the average speed. Average speed for a journey O to D and then D to E. Now we wanted to calculate the average speed of an object when it travels from O to D and from D to E. So what will be the speed? Average speed? Average speed in this case will be total path length. Then what will be the total path length? That will be this distance plus this distance. So distance will be 80 meter plus how much distance the object has traveled from D to E? The object has traveled 20 meter distance. 20 meter distance. And how much time the object has taken? To reach from point O to point E, the object has taken 14 seconds. The object has taken 14 seconds. So what will be the answer? Final answers? That will be 100 meter divided by 14 seconds. So the final answer will be 7.142 meter per second. This will be the average speed. I hope this concept is clear. So once again, to find the average speed, just we need to find what is the total length, path length the object has covered divided by total time the object has taken to reach from initial point to the final point where you wanted to calculate till where you wanted to calculate your average speed. Now let's look at average velocity. Average velocity is defined as the displacement divided by the time interval. So you will see here the average speed is the displacement divided by the time interval. Time interval. And since this average velocity give magnitude as well as direction, that's why it is a vector quantity and its unit is also meter per second, same as the average speed. So now we will look again the same example. So here again the object has traveling from origin O to point A, B, C, D and E. Now here we will calculate the average velocity when object move from O to D. So in this case, first you need to find the displacement. So we will find first displacement. What will be displacement? Displacement says the final position, that is position D minus position initial. So what is the final position? Final position we have here at point D is 80 meter. We will write here 80 meter. And what is the initial position? Initial position is 0. We will write 0 meter. So the displacement in this case we have 80 meter. So like this you have to find your displacement. Final position minus initial position. Now let's look at the time interval. Time interval for O to D. What is the time interval? Interval is this one, 10 seconds. So we have 10 seconds. So we can now find the average velocity. Average velocity is equal to xd minus x naught divided by time interval, that is 10 seconds. So we have 80 meter, that is the displacement, and 10 seconds. So this is equal to 8 meter per second. And it is same as the previous case for OD. You will see 8 meter per second average velocity, and you will see here for O to D you have also 8 meter per second. For this case, this one case, the average speed and average velocity is same. But now be careful, in next situation it will be different. How? Let's see. Now we will calculate the average velocity for O to D and D to E. You have to pay attention at this point. Now let's calculate the displacement again. Displacement. So what is the displacement? What is the final position? E is the final position, because now we are looking at the motion from D to E, this point. So final position is, your final position is 60 meter. 60 meter. And what is your initial position? Same, 0. 0 meter. So what is your displacement? 60 meter is your displacement. And what is the time interval? Time interval. So what is your time interval here? The time interval is 14 seconds. So here the axis is, this axis is time in second. So you have the time interval of 14 seconds. So the average velocity will come out to be, average velocity is 60 meter divided by 14 seconds. So what will be the final answer? The final answer will be 4.285 meter per second. Now you will, when you will compare this value with this value, it will be different. So average speed and average velocity are not same for motion from O to D and D to E. So there is a difference between these two motion. Since in this case our displacement is positive, therefore our average velocity is also positive. So our average velocity will be positive. So if you will look carefully, the average velocity is the slope of the line that is connecting initial point from where the object started moving to the object where its end, that is point E for this case, ODE case. The slope of this line, will give the average velocity for ODE case, because the slope of this line will be this point, that is 60 meter, divided by this point, that is 0, divided by time, that is 14 minus 0. So this will be the average velocity, and same thing we have here. Similarly, for first case, for the average velocity of OD, if you will draw the straight line from this point to point D, and if you will find the slope of this line, that will be the average velocity. This is the average velocity for OD. Now let us take another example, that is this one, where the object, initially the object is at 70 meter, then it's coming to the point A, then point B, and then finally at time equal to 9 seconds, the object is at point C. Now we need to find first the average velocity and average speed when the object has traveled from O to B, then from B to C. So our average velocity will be equal to position at C minus position at O, that is final position minus initial position, which is the displacement, divided by the time, final time, that is time c minus time 0, then when the object is at time equal to 0. So this will be our average velocity. So if we will calculate at x equal to this point, that is C point, the object is at 40 meters. So we will write 40 meters. And initially at point O, our object is at 70 meter. And how much time the object has taken? The object has taken 9 seconds. So 9 seconds, and t equal to 0, t naught will be 0 seconds. So this will be equal to negative 30 divided by 9, which is equal to negative 3.33 meter per second. And since you will see your displacement is negative, this displacement is negative, this displacement is negative, so you have a velocity vector in opposite direction, and it is opposite with respect to position O. It is negative with respect to position O. And as I have told you earlier, the slope of this line, if you will draw the slope from this point to this point, this point to this point, this is the slope of OC, OBC, which is negative, and this slope gives the average velocity. Now we will find average speed. Average speed. What will be the average speed? As defined earlier, average speed is the total path length of OBC divided by time interval. So what is the total distance? That is 50 plus, and from B to C the object has covered how much distance? It has covered 20 meter distance. And how much time does this has taken? The total time is 9 seconds. So what will be the final answer of the speed? Speed will be equal to 7.77 meter per second. So you will see, for the same point, for the same journey from O to C, the average velocity is negative 3.33 and average speed is 7.77. So from this point, one conclusion you can make is average speed is different from the average velocity.